Good morning, everyone. My name is Wubishet Bekele. I work for Agriculture and Agri-Food Canada, and I'm going to share with you my experience trying to implement genomic selection in outbreeding programs. My journey started when I joined Nick Tinker as a postdoc some 10 years ago, and I'll try to summarize what I learned the past 10 years in 10 minutes. Wish me luck. Before I do that, I want to tell you a little bit about the public outbreeding program in Canada. There are 3 outbreeding programs. One is in Eastern Canada, it's EUCARPIA, and 2 of them are in Western Canada. One is Aaron Beatty, he's working at the University of Saskatchewan, and Kirby Nielsen is also working for AAFC. In Canada, there are 3 outproduction or out-mega environments for breeding. Mega Environment 1 is in Southern Ontario and Eastern Canada, and Mega Environment 2 is the rest of Eastern Canada. Even though Mega Environment 1 and 2 represent only 10% of the acreage, it's more complicated to breed there. And I want you to pay attention to Ottawa, because that location is acting sometimes as Mega Environment 1, and sometimes it acts like Mega Environment 2. And that's where EUCARPIA is working as a breeder. And most of the production happens in Mega Environment 3, or the rest of Western Canada, and the environment there is more uniform, and they belong to one. About our GS, thanks to Gary, he talked about breeding processes, and I'll briefly explain EUCARPIA's breeding program. He has a generation advance. We have a very good greenhouse and accelerated generation advance, and the first 2 years he can reach to F4, and then early stage selection happens visually. For those of you who do not know what that is, these are called hill plots, and he would go through and reduce the numbers, and the numbers are shown there. And from year 5 to year 9, he would run field experiments or replicated field trials, and it starts at home test. And it's around 300 lines which are going into home test, and then he would pick some 60 lines which he calls preliminary yield trials, and he would also contribute those 60 lines to a common trial between the 3 breeders, the 3 public breeders called Encore, and those are tested in the star locations, so 4 locations across Canada, and each breeder would also test those lines at 10 sites of their regions, but only the 60 lines from their programs. So that's how they have been doing their breeding, and as you can see, he reduced it from more than 10,000 to 300 in 2 stages of visual selection. And we started working or playing with genomic selection around 2016, and the goal was to improve the accuracy of breeding or selection, the visual selection, using data from the advanced yield trials. But you may wonder why. Why are you starting in 2016? And it's because we developed a genotyping method suitable for oats at the time, and it was giving us more SNP data, and it had also a production system which can give us a good number of markers, and we could also show that the cross-validation accuracy is good. And then in 2016, we started by saying, okay, EUCARPIA will select the lines, and would also predict the lines. And the goal was to do the genotyping prediction as well as take the phenotype the same year and then try to predict. And of course, we failed because it was not possible for us to do genotyping, phenotyping prediction before harvest, and the breeder was not harvesting everything in the observation plots. So I had to keep some panicles in our lab, and we had some issues. So the next year, what we did was we got the seeds when they were planting the nurseries, and we did it in 2017, and we did the genotyping ahead of time, and then we delivered genomic estimated breeding values of the lines or the phenotypes, and the two traits we considered were yield and beta-glucan, and then we tested those lines, which were predicted to be top yielding or genomic selected lines, and we also predicted genomic culled lines, or which were predicted to be low yielding and also low beta-glucan. And we also compared them in the first home test trials together with the breeder selected lines or visual selected lines. And yeah, we were happy that the genomic selected lines performed better than genomic culled as well as breeder selected or visual selected lines. And to our surprise, one of the lines which was selected by genomic selection but not selected by WICA at the time became a variety, and it was released in 2023, and we named it after one of the pioneers of genotyping at our center. And there was also another line which was selected by both visual selection and genomic selection, which ended up becoming a variety, and which is also named after another famous breeder. But visual selection is still very successful, and it's still the main way of selection and variety development, and AAC White and AAC FEDAC were also selected, released from the same cohort. So it must be a very good cohort. And what really surprised us is we used a single year and single training population, and then it gave us such a good result. And we think this is maybe because of the related training and test sets. And also it might be because 2016 was extremely dry and there was little pressure. And Mega Environment 2, the place where these lines performed well, is there is no disease in that location, so that's why maybe the training data helped us to do that. So since 2018, when we had a new cycle of funding, we were a little bit maybe too confident, and then we said, okay, let's do this at the F5 stage, so one stage earlier, and we are getting the lines, we grow them in greenhouse, and then we keep the seeds, and we keep it with our team, so it's not going back to the breeder. And then the breeder was also doing visual selection from the same crosses which he provided to us. And then what we also did was we also tried to include some long-term checks, and we would predict the lines and then send 80 genomic selected lines and 60 visual selected lines to New Zealand, and then when they come back, they join the home test or our validation trials. We also improved the we reduced the genotyping cost by developing a G-based capture. And I mean, I don't want to go into details, but we also reduced it again by using another method called nano-G bias. But the good thing about all this is we can generate genotype data very quickly and without compromising our prediction accuracy. And for example, for GS 2024, I could generate genotype data for more than 27,000 lines within half a day. And for those of you who worked with genotyping, this is quite quick, and it helps a lot to deliver genomic estimated breeding values in time for harvest. I don't want to talk about it here, but this is how we selected the lines which are going into those validation trials. So we did this for something like 6 years, and WICA somehow summarized the results in these two tables. I would say the year you see here, the years you see here are the years of the validation experiments. That means those lines were selected one year before that. Unfortunately, there were no visual selections we could do in 2020. For that reason, 2022 numbers are double. because both 2020 and 21 were tested in 2021. And in 2024, we moved into a more mega environment specific type of GS, and for that reason, the numbers are slightly different. But when you look at AROA, the GS is genomic selected top, GC is genomic culled lines, and GS over VS means the advantage of GS over the visual selection or GC. And the take-home message is it could improve yield by 2.5% on average when you look at all the lines here. But for AROA, the opposite is true, except for 2023, where we had a huge advantage over visual selection. And this is because of most probably the 2022 year, which was too similar to, or I don't know, different compared to any other year. And it was the GS lines performed the worst this year, and the next year it was beaten by VS, by GS. In Western Canada, it's slightly different. The forward validation accuracy is very high. I don't know if you noticed, but our cross-validation in the East is around these numbers for yield. And they have a selection for disease at F2, and then we select F3 and F4 through genomic selection. And in here too, we released one variety last year, which was selected by GS in 2019. And there are also some two lines which are now at the last stages of genomic selection, which registration trials which were selected by genomic selection. Learning from all these things, we have tried to implement genomic mating in another funding cycle, and we are implementing that for all 3 mega environments, leveraging all the data we have accumulated. And we are also developing mega environment specific genomic selection models for all 3 mega environments and testing all the lines. And with this, I would like to summarize. We streamlined field to bioinformatics workflows through a learning by doing approach. We reduced genotyping, and our throughput by now is 10,000 lines a year. Yield trials enabled us to develop GS models that could help us to do genomic culling and selecting top lines. Encore and especially the advanced trials are quite useful. Currently, we can predict more than 35,000 data points within hours using the method mentioned there. And we suggest visual plus genomic selection or the pre-2018 scheme because the 2 varieties were selected through that method. And we are applying all this, and the next GS won't be only based on our practical issues. It will be based on genetic simulation and pangenomics. Thank you.
Thank you very much.